Yeah, very good morning, students. In this video, we are going to discuss about the one important problem in the electrostatics. The problem is you consider the two particles like this, each particle having the 5 gram mass. Each particle having 5 gram mass. That's okay. And each particle having the charge, that is a q1 charge, q2 charge. The both charges are having 1 into 10 power minus 7 coulomb. Like that, in the q2 also we are having 1 into 10 power minus 7 coulomb. So q1 is 1 into 10 power minus 7 coulomb, q2 is same 1 into 10 power minus 7 coulomb. Both are same, that is 5 gram mass. So now you consider that both the particles stay in limited equilibrium on a horizontal table with a separation of 10 centimeter between them. Means the distance from this point particle to this particle, that is 10 centimeter. And these particles are present on the horizontal table, making a limiting equilibrium, right? So now we have to think about this one point that is given: coefficient of friction, the friction between the table and the charge, and that coefficient of friction between each particle and the table, right? That is the same coefficient of friction between each particle and the table is same. Okay, so now we have to find out the value of the coefficient. So what is the value of the coefficient? That the coefficient value that we have to find out. So before find out the frictional force in the limiting equilibrium, F is equivalent to mu mg. That is a formula for finding the frictional force in the limiting equilibrium. So this frictional force between the charge and the table, that will be equivalent to the force between the two particles. So first we have to find out the force between the two particles. What is the formula for find out the force between the two charged particles? That we know 1 by 4 pi epsilon naught q1 q2 by r square. So first we are going to calculate the force, means the force between the two charged particle. Both charges are same charges. So what will be the force? F is equivalent to, so instead of this 1 by 4 pi epsilon naught, we may consider the 9 into 10 power 9, because epsilon naught value, if you substitute it, what you will get? 9 into 10 power 9. So just substitute 9 into 10 power 9 into, and this q1 q1 charge is nothing, 1 into 10 power minus 7. Q2 the same, 1 into 10 power minus 7. So we can multiply 1 into 10 power minus 7 the whole square divided by r square. What is the distance between the two particles? That is a 10 centimeter. That is 10 centimeter. Now we have to make r square. 10 centimeter means 10 into 10 power minus 2, or simply we may put 0.1. So 0.1 meter, 0.1 into 0.1, or 0.1 whole square. So if you multiply it, what you will get is very simple. After the multiplication, after making the simplification, what we will get? This is very simplest one. The F, that is nothing but 0.009 Newton. So that force between the two charges, that is nothing, 0.009 Newton. So this is a force between the two charges. Now we have to equate this one with frictional force between the each particle at the table. Okay, so What is the formula for the frictional force? This one. So F is equivalent to mu mg. We don't know exact value of the mu, but that value we have to find out. So if you substitute here, this F is equivalent to mu that we don't know, and m that we know very well, 5 gram mass. So 5 into 10 power minus 3 gram. G, that is nothing, 9.8 meter per second square. That's okay. So F is nothing, that is after the multiplication with 9.8 and 5 into 10 power minus 3, what you will get 0.049 mu Newton. Okay. So this is the frictional force. This is the force between the two charges. So both will be equal in this situation. So we have to equate these two. So if you equate it, what you will get 0.009 and equivalent to 0.049 mu. Both are Newton, right? So mu is equivalent to 0.009 divided by 0.049. See, after the cancellation, what you will get? 9 by 49. So, sorry, 4.9. That way you will get. So, actually, what you will get after getting the division, that value it is around 0.18. That value it is around 0.18. So that is the answer. So answer for this question is the coefficient value, that is nothing, 0.18. That is the answer. So answer for this question is mu is equivalent to 0.18. So they find the value of the coefficient for this situation. That value, that is around mu is equal to 0.18. That's all. So in this problem, first we have to find out the force between the two charges, and then we have to find out the frictional force. After that, we have to equate the both the forces. After equating the both the forces, what we will get finally, we will get the exact value of the coefficient. So the coefficient value for this problem, for this situation is, that is nothing but 0.18. Okay students, thank you. So we will discuss the one more questions in the next video. Thank you so much.